These are the results from the quiz. Let's see who did some top scores. Scart looks like was our winner. Scart, good job. Scart looks like he got first place. Where's Scart? Let's see. Good job, Scart. So Scart, and then Alex, Pasta, Lisa, all came in second place. And then Pasta and Pasta came in third place as well. But yep, Scart had the highest score. You can see your scores here. You guys look like you did very good on this quiz, though. A lot of you guys got 100%, 80%, 70%. I would say as long as you got above a 70%, you did good. As long as you got above a 70%.
Go down and
What's above?
I mean go down to the
how
bottom.
many percents?
70% looks like this. 73% is good. 73% is good. I'd say anything above 70% is good.
Or can you go down because
yeah.
Why pass that try so many times?
He was trying to go for the high score. Yeah, guys, sometimes you can take the quiz more than once if you want. You can take the quiz more than once if you want to go for the high score. Pasta was probably going for a high score. Okay. Good job, everyone. Good job to Scart. He beat everyone by a lot. 700 points. 700 points. That's a good amount. Okay. So let's see what questions you guys missed. So the most missed question was while touching the Van de Graaff generator, each of Zoe's hairs has which of these? The correct answer was the same charge. We have opposite charges, opposite charges. Let's look at this real quick.
Which magnet is stronger than the I can see that.
I don't think so. I think that's one of the strongest magnets. But is there another stronger magnet? Are you asking? Neodymium is the strongest that I know about. But there's electromagnets that are stronger. So you can see Zoe's hair. You can see Zoe's hair in this picture. You guys see her hair? Now, does it look like her hair is attracted to each other? Or do you guys think it is repelling each other? What do you guys think? Moon, what do you think? Moon, do you think it's attracted to each other or repelling?
Repelling.
It's repelling, exactly. Let me clear this. Clear all. Okay. Let's go over any of the other questions. So you guys got this one. So they have the same charge. They have the same charge. Because same charges do what? The same charge will repel, or retract. Ray. Same charges repel or retract or attract.
Charges repel.
They repel, so the answer is same charges. If you put opposite charges, what do opposite charges do? Jackie, what do opposite charges do?
Opposite charges attract.
Yeah, they attract, and her hair is not attracted, so the answer is same charge, same charge. The second this question is the girl's hair and the comb are attracting one another. The hair and the comb have, so if they're attracting, what type of charge does it have to be? Scart, if the hair and the comb are attracted to each other, what type of charges does it have to be? Opposite or the same? If they're attracted.
Opposite.
Opposite. Very good. So that's why the answer is opposite. If you guys put like charges, if they were like, they would repel. If they were like, they would repel. Two balloons are hanging from a stick. One balloon has a positive charge and the other one has a negative charge. How would you expect the balloons to behave? Would they go towards each other or away from each other? Lucky, what would they do? Towards each other. Towards each other, guys. Remember, the charges are opposite, so they attract. They will want to come towards each other. Okay, that was your homework. We're going to take another quiz today so we can see if you guys can improve.
Yay!
You guys can compete for another high score.
Electricity.
Okay. Okay, today we're going to be learning, we're going to focus on electromagnets. Electromagnets, okay? We saw them last class a little bit. We just did your homework check. What is an electromagnet? What is an electromagnet? Let's look at the word for any clues. What are some clues that you guys see in the word electromagnet? What are the clues? What do you guys think? Emma, what do you think a clue is? How can we figure out what electromagnet means? What words do you see in there? Make sure your camera is on. What words do you see in there?
Magnet.
Magnet, very good. And cherry, what is our other word that's in here? Cherry, let me call on cherry. Cherry, what's the other word that's in here? Guys, make sure you guys don't unmute yourself, okay? Unless you're called on. Cherry. Let me find cherry again. Cherry, what's the other word inside of this?
Yes.
Okay, so we have the word electromagnet. We've already looked at the word magnet. What's the other word that makes up electromagnet? What's the other part, Cherry? Just say it. Can you say this for me? Just say this part, the left part.
Electro.
Electro. What does that word sound like that we've learned about? Does it sound like magnet? Does it sound like gravity? Does it sound electricity? What word, what vocab word does it sound like?
Electricity.
Electricity. So guys, this is electricity and a magnet. Let's look. Electro and magnet. What do you think electro means? Electricity. Good job, Cherry. Good job. It's electricity. Electro is electricity. And can someone read the definition of electricity for me? Let's have Taylor. Can you please read the definition for us?
Electricity is a form of energy and is the flow of electrical power or charge.
Very good, guys. If you guys have, if there's electricity is just the flow of power or a charge of a charge. It's the flow of something called electrons. Electrons. If you guys have ever heard that word, electrons, it's the flow of electrons. What do you guys think magnet means? What does the word magnet mean? Moon, what does the word magnet mean?
A magnet has two poles. That's one is the north and one is the south.
Very good. So we have the word magnet. It's an object that attracts things made from certain metals. Like Moon said, with the North Pole and the South Pole, it attracts things with some certain metals. So an electromagnet must be is a form of energy that is the flow of electrical charge. So it's a magnet, but it needs an electrical charge. Let's watch a video and then we're going to go through your reading. Let's watch the video and then we'll go through your reading. So let me share the video with you guys with sound. Okay. So we're going to finish watching this video. We're going to watch the electrical magnet part. Okay.
Junkyard magnet that can be turned. When I hit this button, the magnets will be released. 3, 2. It's called an electromagnet. This is an electromagnet I made from a nail, wire, and a regular battery. When electricity from the battery flows round and round through the coil of wire,
it creates a magnetic field.
When the battery is on, it can pick up paper clips like a magnet.
How many materials do you need to make an electromagnet? What type of materials do you need to make an electromagnet? Sophia?
3.
3. What are they? What is he holding in his hand right here? In his left hand, what is he holding? What's he holding right here? What is this called? Sophia, what is this called?
That's Mr. Connor.
What is this called?
I can't hear.
You can't hear me?
Yes.
Okay, okay. I'll call on someone else real quick. Scart, what is this called?
Battery.
A battery. And what are the other 2 materials? What are the other 2 materials? Let's have Rose. Rose, what are the other 2 materials?
It's electric.
So we have battery. What's the other materials? We have 2 other ones.
It's electric.
The wire? Are you trying to say the wire? Okay, so there's the wire, and what's the last one? Alex, what's the last material? Battery, wire, and
Paper clips.
not paper clips. What's on the wire? What's in between the wire? What is that called?
A nail.
A nail. A nail. Why is a nail important, do you think, Alex? Why is a nail important? Okay, guys, you keep on muting before. Can we
I know, because nail is made of iron.
Mm-hmm.
Maybe something like this one. Looks like it's made of nickel or cobalt.
Oh, nickel or cobalt. Very good. Yes, so guys, this is a nail can be magnetically charged because it's made out of metal, made out of iron, cobalt, nickel. Very good. So that's what you need. You need a piece of metal, electricity, and a battery. Okay, let's learn more about electro. Okay, now let's read page 120. Everyone get out page 120 of their book. Page 120. Everyone needs to get out their book. Okay, let's read our page. Let's have Zook read the first sentence.
Because how some magnets in the home are electrical.
Okay. Kim, can you read the next sentence?
Such magnets are called electromagnets.
Very good. Any magnet that uses electricity or are electrical is an electromagnet. Remember how we broke up the word electro and magnet. Rose. Where is Rose? Rose, can you read the next sentence for us? Okay.
What is it, Star?
There you go. Okay, so electromagnets?
Electromagnets are a kind of
Temporary?
Magnet.
Very good. Banana, why are we unmuting? Please stop. Thank you, Rose. Temporary. Good job, Rose. And Taylor, could you read the next sentence for me? Oh, I can't.
Electricity passes through wires routed around a piece of iron. It causes the magnet to become
Magnetic.
magnetic.
Can you read the next sentence too, Taylor?
When the electricity is turned off, the
magnetism
goes away.
Taylor, why do you think the magnetism goes away if we turn the power off or is turned off? Why does it stop becoming a magnet?
If the electricity is turned off, turned off, so it has no more energy.
Yeah, it has no more energy. And this magnet needs what to work?
Energy.
Yeah, it needs electricity. So if it doesn't have energy, the magnet turns off. The magnet turns off. Can a normal magnet turn off? Can a bar magnet turn off? The north and south when it's the bar, can that magnet be turned off? No, it can't be turned off. So that's why electrical magnets are really useful, is because you can turn them on and off. You can turn them off. Normal magnets, you cannot turn off. You cannot turn off. Okay, that's why they're so useful for scientists and engineers, and that's why they're used in your home for the fan. Imagine we used a normal magnet for your fan. What would happen if we just used a normal magnet for your fan? Misha, what would happen?
Yeah.
If we just used a normal magnet for your fan, would it ever turn off?
No.
No, it would stay on forever. The magnet would slowly lose its charge over time, and then it will eventually stop. But an electromagnet can go on forever as long as there's what, Misha? The electromagnet can go on forever as long as there's what? What do you think, Misha? As long as it has... Sam, what do you think?
Can you say again?
Yeah, so a normal magnet would not turn off. It would just have your fan keep on going and going and going until the magnet ran out of energy. But an electromagnet wouldn't run out of energy. Why does the electromagnet not run out of energy?
Because in its name, electro, so it needs to use energy.
Yeah, so it can use electricity, right? As long as there's electricity, your magnet will work. Your magnet will work. Okay. Pasa, please stop asking for control.
I got a question too.
Yeah, what's your question?
Why do the magnet too strong that can, like in the video laboratory?
What's the strongest magnet? Or what's your question?
Pass through the food.
Oh,
Why
that's
do the magnet strong that?
Yeah. Well, what's the magnet trying to get to, Sam? What is each magnet trying to get to?
Other.
They're each other, and what's in the way of getting to each other?
They pull toward it.
Yeah, the fruits. The fruit's in the middle, right?
Crash. Yep.
So they have to go through the fruit to get to each other. They're so strong, they can crush the fruit. If they weren't strong, the fruit would not be crushed. but they're so strong they can crush the fruit. Okay, let's watch another video Mr. Connor has about electromagnets. Okay, let me make sure the share sound. What do you guys think is going to happen if he makes electricity run through this wire and an electrical field is made? What is going to happen to the magnet or the compass? What do you guys think is going to happen to the compass? Milk, what do you think is going to happen to the compass?
I think.
So he's about to make an electrical charge go through the wire, which is going to cause a magnetic field or an electrical field. What is going to happen to the
The compass will go inside.
Okay, let's see.
Piece of wire to a battery. It makes the compass needle move just like a magnet did, so we know the wire must be moved just like a magnet did. Sorry. It makes the compass needle move just like a magnet did, so we know the wire must be creating a magnetic field. This magnetic field takes a circular shape around the wire like this. However, the magnetic field around a single straight wire is very weak, not enough to pick up even one of these paper clips. You can make the magnetic field much stronger by wrapping the wire into a coil called a solenoid. This causes the field around each individual. However, you'll see that this coil of wire is still too weak to pick up an individual paperclip. To make an electromagnet really strong, you need to add a ferromagnetic core like this iron bolt. Ferromagnetic materials have many smaller individual.
So guys, if you're wondering why metal is magnetic, is because it has all these north and south, north and south, north and south, north and south, north and south. And when it's a magnet, they all get aligned. They all get aligned like this. So let me show you real quick. So this is what a piece of metal looks like. And then when it's introduced to a magnet, it looks like this. All the north and south are going the same direction. But before, the north and south was going in all different directions.
Magnetic domains. Normally, these domains are aligned randomly in the field, making the. Unlike a regular magnet, an electromagnet can be turned on and off by removing the flow of electrical current. If you reverse the direction of the electric current, you reverse the direction of the magnetic field. To change the strength of an electromagnet, you can change the number of turns in the coil,
so once
the
again,
length
he's
of
using
the coil,
a battery,
the amount of current flowing through the coil,
and
or
a
the
piece
core
of
material,
metal or a piece
all
of
of which
iron.
would make a great science project. Because this video was just for a demonstration, but you should not.
Okay.
Hi, this is.
Okay, let's do a little bit of writing. Let's answer question number 16. What causes an electromagnet to pick up scrap metal? What causes an electromagnet to pick up scrap metal? Okay. You guys can all answer in your book. Guys, make sure you have a piece of paper or pencil. We are going to write down these answers in your book. Okay. Write down what causes an electromagnet to pick up scrap metal. Okay, we'll go over your. Okay, give everyone a little bit of time to think of their answer, and then we can. You can share your answer. Okay.
I finished it.
Did everyone finish?
I finished.
Okay.
I finished. This is the homework.
Okay, I didn't know if you guys did this and the quiz. Okay, I thought you guys just did the quiz, but that's okay. You guys can share your answers. Let's hear some of your answers. Let's see who hasn't gone yet. Jackie, what did you write down then? Jackie, what did you write down? Okay, I'll call on someone else. Let's have Bunny. What did you write? Bunny, what did you write?
I think it can act a distance because it has two poles to attract metal.
Very good, Bunny. I like your response. I like your response. Let's have Ben 10. What did you write down? Ben 10, what did you write down? Ben 10, what did you write? Okay, I will call on someone else. Blue Moon, what did you write about? for 16? Blue moon. Okay, blue moon, make sure your camera's on. I can't even see you. Sino, make sure your camera's on. Pasta, make sure your camera's on. Pasta, what did you write down? Okay. Pasta, we're not able to hear you. Make sure you check your microphone, see if it's working, okay? We can't hear you. I don't know what's happening. Why is no one unmuting? Let's just see. Let's call on Sino. What did you write down? Sino, what did you write down?
But yeah. I write the electromagnet have electricity goes to a wire that can pick up scrap metal.
Yeah, the electricity produces a charge and that can pick up the scrap metal. Will it be able to pick up plastic? Is an electromagnet able to pick up plastic? What do you think, Sino? Or can it only pick up metal?
Because magnets only take up some kind of metal.
Yeah, it can only pick up metal. It can only pick up metal. Imagine if someone made a... Imagine if we made a human magnet that could pick up humans. That'd be awesome. That'd be awesome. Emma, what did you write?
The many small magnets stick together and make a big magnet for the electromagnet to pick up scrap metal.
Okay, and what do you need for the electromagnet? You need magnets, and what's the other thing, Emma? You need a piece of metal and what going through it? What? Electricity?
No, electric.
Yeah, the same thing. Electricity is correct. It needs electricity. Okay, let's look at the teacher's answer. Possible answer: when the switch is turned on, an electrical current flows. The electromagnet becomes magnetized. It is able to pick up scrap metal because of the magnetic attraction. Okay? It becomes magnetized when there's electricity flowing through it. Okay, let's see what you guys answered for number 17. Explain how magnetic and electrical forces act across a distance. Okay, how do they act across a distance? Do they get stronger? You guys should talk about, do they get stronger or weaker the further you get? Stronger or weaker? How about Ray? Are you there? Ray, what happens to magnetic and electrical forces? Do they get stronger or weaker?
The stronger the magnet is, the further, the bigger the magnetic field is.
Yeah, the bigger the field is, the stronger it gets. The bigger the field, the stronger it gets. Very good. What did Banana, what did you write for your answer? Banana, what did you write for your answer?
Yeah.
Okay, read it for everyone, okay? Okay, I'll call on someone else. So guys, if you don't have an answer, just say, I don't have an answer, so I can move on to someone that does, okay? Today's been really slow with moving on to people. Taylor, what did you write for this? Taylor. Are you there, Taylor? Maybe Taylor went to I think Taylor went to the bathroom. Puppy, what did you write down for number 17?
I write magnetic and electric force act across magnetic field and electrical field. My example, a toy seahorse pulling sand, a pen being rubbed on a fur pulling thin pieces of tissue need close distance.
Good job, Cherry. You have your example of static electricity is great, and your example of a magnet is really good as well. Okay, let's look at the teacher answer. Magnetism, let's have someone read this. Let's have Sino. Can you read the answer for everyone? Sino. Magnetism.
Explain how magnetic electric force act across a distance. Use two answers in your answer.
Okay, and Kim, can you read the answer for everyone? Kim, could you read the answer on the screen for everyone?
Possible answer. Magnetism. Magnetism and starting electricity can both apply force across a distance to make things move without contact. A magnet can pull a paper clip, and starting electricity can make hair stand up.
Thank you, Kim. So, guys, you had to answer two different things. Explain how magnetic and electrical forces act across a distance. And then you had to give two examples, which is the second part. You had to give two examples. Their first example is a magnet can pull a paper clip, and the second example is static electricity can make your hair stand up. So make sure if it says use two examples, you give us two examples of magnet and electrical forces. But for your homework, number one, make a list of the materials you would need to make an electromagnet. So write down a list of all the materials you would need to make an electromagnet. Make a list. You do not need to make an electromagnet. Just make a list. Write down a list of the materials you would need to build yourself an electromagnet, and write to explain how you would test the strength of the magnet. Okay, of the magnet. I guess I